Module 3, Lesson 15. We are winding down this module, so of course they're going to hit us with the word problems, okay? So these are multi-step, which means there could be some addition, there could be some subtraction, okay? You have to read carefully and assess reasonableness of solutions using benchmark numbers. Remember we said our benchmarks for fractions are usually 1/4, 1/3, 1/2, okay, 3/4. These are all fractions that we should recognize and understand their sizes, right? And reasonableness means that we might be doing some estimation. When you see reasonableness, estimation, that's what that means. Okay, multi-step, addition, subtraction, word problems, ding, 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 ding. I love word problems. Estimation with our benchmark numbers. So please go to the Learn book, Lesson 15. Pause the tape if you need to. Get out your Learn book. Solve the word problems using the RDW strategy. You remember that as read, draw, and write, which means we'll probably use some tape diagrams, maybe some other strategies like that. Okay, show all of your work. Some of you like to turn in your exit tickets without any work on it. I will not give you a 3 ever, ever, ever on an exit ticket that does not show all of your work, even if you have the right answer. In a race, just as a warning, in a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. Okay. The third place finisher, so here's the winner. Okay, I'm going to put that as the winner. Right? Then, okay, and the second place finisher was here 1 1/3 minutes later. So we don't know what this number is yet. The third place finisher was 1 3/4 minutes after that. Okay. The third place finisher took 34, so we do know this number, 34 minutes, 34 2/3 minutes. How long did the winner take? Okay, so here's why we drew a diagram. Here's our tape diagram. We knew that the winner won, that the second place person was 1 1/3 minutes after that winner, and that the third place person was 1 3/4 minutes after the second place winner. So what can we do here? What strategies can we use to solve this problem now that I have read the problem and I know that minutes are my units? I drew my tape diagram, okay? And now I'm going to create an equation or expression to solve this. So this is the number that I'm starting with. This is the big number. So 34 2/3 minutes minus, and then I want to add those together, 1 1/3 plus 1 3/4. And that's going to give me the winner's time, okay, in minutes. Now that I have my drawing and I have my equation here, my expression, I can solve the problem. So always, always tackle what's inside parentheses first. So here we've got 1, and my common denominator here is going to be 12. If you don't know why that's 12, then come see me. But 3 times 4 is 12, so that's going to be our common denominator. And this is going to be 9/12, and this is going to be 4/12. And then that all together is going to be 1 and 1 is 2, 9, 10, 11, 12, 13 twelfths. And 34 2/3 minus 2 3/12. Now, do you see this? It's got that improper fraction in it, so let's go ahead and change that right away. Okay, now I'm going to rewrite my problem up here so that I can just kind of keep my flow going. 34 2/3 minus 3 1/12. Okay. So in order to solve this, I need common denominator. I'm going to use 12 again. 34, and if this is 12, that means I multiplied by 4. 2 times 4 is 8, minus 3 and 1/12. 31 minus 3 is 28, and 8/12 minus 1/12 is 7/12. Does that seem right? It kind of doesn't, actually. Let me see what I'm doing wrong here. Let me see. I'm going to check my work, okay? It's really important to check your work if you have any doubts or if it doesn't seem right. Does this make sense, right? So here's what my winner was. So I'm going to draw this in here. 28 and 7/12, that's close to 29, plus 1 1/3 plus 1 3/4. That should equal 34 2/3. So I'm just going to add it up really quickly to see if that's the same answer here. It doesn't quite look right, does it? No, it definitely doesn't. I've done something wrong. Let me check. Let me check my work here. This would be 28, 29, 30, right? Plus 7/12. And if I were to use my estimation, plus 1/3 plus 3/4, that's not going to get me to 34, is it? So I've done something wrong. So let's check. I want to check my work again. Okay. So 1/3, 1 1/3, right? Plus 1 3/4 there. So let's add those together. 1 1/3 plus 1 3/4. So that's 1 4/12. That's right, because that would be multiplied by 4, and this would be multiplied by 4. And this would be multiplied by 3, and that would be multiplied by 3. So that's 1 9/12. So 1 and 1 is 2, and 13/12, but it's actually 3/12. So I think I made a mistake when I subtracted. Ha! I know what I did. Look at this. I subtracted it twice. I subtracted it twice. Isn't that interesting? No, I didn't. I know what I did again. It was a marker problem. I've been having these marker problems a lot. This right there should be a 4. Do you see? That's my mistake right there. I drew it as a 4, and then the 4 got erased, and then that's my problem. Okay. Thank you for those of you who are paying attention. You know who you are. Okay. If we go back and watch the video, I bet you can see where I drew it as a 4, and then the first part of the 4 got erased. Now, 34 minus 3 is 31 and 7/12. If I change this into 31, that would be 31, 32, 33, that's getting closer, plus all those fractions. That seems much more reasonable, doesn't it? So how long did the winner take? 31 and 7/12 minutes. There's my answer. Now, when you make a mistake, try to catch it. Try to check your work. Make sure that your answer is reasonable. That's why we show all of our work, so I can go back and find the mistake. And I did find it. I found it right there, right? Number 2, John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. You don't have that problem in Venezuela, but in the north, where I am from, the ice gets on the sidewalk. Every time it rains, it turns to ice, or the snow sometimes when it melts, it turns to ice, and you can slip and you can fall, and it hurts, and you get a bruised butt. So if you put salt on the ice, the salt will help melt it, okay? And we'll learn about that in mixtures and solutions in science class, okay? You can try it if you want. Get out an ice cube and put a little salt on it. It will melt. He then used another 3 4/5 kilograms on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? Okay, so let's try to figure this out. He had 1 3/4 on the sidewalk, and then he used another 3 4/5 on the driveway. Okay, see, this is this pen. It looks like a 9, but it's only a 4. And if he originally bought a 10-pound bag, so all the way over here was 10 pounds, 10 kilograms. We need to figure out what that is. So first of all, we're going to add that, and then we're going to subtract it from 10. So our problem is 10 minus 1 3/4 plus 3 4/5 equals how much is left, right? That have left, that's an indicator of subtraction, right? So here's our problem. Our common denominator is going to be 20. 4 times 5 is 20. So 1 plus 3 over 20. So this would be 16, and this would be 15, which equals 4 31/20, which actually equals 5 11/20. So I'm going to move the problem over here. I ran out of space. 10 minus 5 11/20. Well, in order to get to 6, I would need 20ths. I would need 9/20 to get to 6, and then 7, 8, 9, 10. Did you see how I did that in my head? 11/20 plus 9/20 would get us to 6, and 4 minus 6 is 4. So how many kilograms does he have left? 4 9/10 kilograms. Number 3. How many problems do we have? 5, yes. Okay. Sinister Stan, ooh, sinister, that means he's bad, stole 3 3/4, oh, he stole, so he is bad, stole 3 3/4 ounces of slime from Messy Molly. I know you guys went through a slime phase last year. Maybe some of you are still in it. But his evil plans, required 6 3/8 ounces of slime. He stole another 2 3/5 of slime from Rude Ralph. How much more slime does Sinister Stan need for his evil plan? So he stole, oh, he's not a very nice guy, 3 3/4 from Molly. But he needs 6 3/8 altogether. And we also know he stole 2 3/5 from Ralph. So this is what we need to find, okay? So this is what he stole from Molly. This is what he stole from Ralph. This is what he still needs, and that's how much he needs for his sinister plan. Ooh. Okay, so first we're going to add that together, and then we're going to subtract it from here. So actually a lot of these problems are starting to look the same. Minus 3 3/4 plus 2 3/5. Okay, is it the same? Oh no, it just looked the same for a second. Okay, so inside the parentheses first, 3 and 4 and 5 are going to give us the common denominator, 20. So that's going to be 20 there, and 5 times 3 is 15, and 4 times 3 is 12. So now 6 3/8. I have 5 and 15, 27 20ths, which also equals 6 and 7 20ths. Now I'm going to move my problem over here because I ran out of space again. 6 3/8 minus 6 7 20ths. So we need to find a common denominator here. Common denominator for 8 and 20. So really we just need to find a multiple of 8. So let's just do our skip counting. 8, 16, 24, 32, 40. 40 should work. Okay, so 6, 40. What did I have to multiply to get by 45, right? So 5 and 5 would be 15. And then this would be 6, and multiply that by 2 to get 40. So 7 times 2 is 14. My new answer is, oh, he's so close to his evil plan, 1/40. 1/40 ounces. He doesn't need much of slime. Gavin had 20 minutes to do a 3-problem quiz. Sounds like you guys. You usually need like 3 hours for 3 problems. He spent 9 3/4 minutes on problem 1 and 3 4/5 minutes on problem 2. How much time did he have left for problem 3? Write the answer in minutes and seconds. Ooh, this is a conversion problem. Okay, well, let's do it in fractions first. So he had 20 minutes. This is how much he started with. That's what he started with. Okay. And so if this whole thing is 20, and he used 9 3/4 on the first problem, and he used 3 4/5 on the second problem, how much time does he have left for question number 3? So 20 minus 9 3/4 plus 3 4/5. So let's solve that. 4s and 5s make 20, so that's 15, and 3, 20, 16, which equals 9, 10, 11, 12, and 31/20, which actually equals 13 and 11/20. So now 20 minus 13 and 11/20. Okay, well, to get to 14, we would need 9/20. And then 20 minus 14 would be 6. Okay, so 6 minutes and 9/20 of a minute. How are we going to convert 9/20 into seconds? Well, you know that 1 minute is 60, right? 60 seconds. So all we'd have to do is multiply that by 3 and this by 3, and that would give us 27 out of 60. So it's actually 6 minutes and 27 seconds. How much does he have for the third question? 6 minutes and 27 seconds. We'll do some more of that time conversion. I think that's important. We haven't touched on that very much. Number 5, last one. Matt wants to shave 2 1/2 minutes off his 5K race time. So he wants to take it off. Shave it off means subtract. After a month of hard training, he managed to lower his time from 21 1/5 down to 19 1/4. By how many more minutes does Matt need to lower his race time? Well, first of all, let's figure out, because this is what we want it to equal, okay? And he's done this already, so let's actually figure out this problem. 21 minus 19 is 2. Wait a minute. Hang on. Let's find our common denominator here. 20 would be 4/20, and 19 and 5/20. Okay, so we're definitely going to need to borrow. So this is going to turn into 20 and 24/20 minus 19 and 5/20 equals 20 minus 9 is 1. 24 minus 5 is 19/20. Okay, so he wanted to shave 2.5 minutes off of his time, but he only shaved almost 2 minutes off of his time, 1 and 19/20. How many more minutes does Matt need to lower his race? So now we're going to subtract this, 21.5. That's what he wanted to, but this is what he did. So this is how much more he needs. And I'm going to turn that into 20ths because that would make the most sense. Minus 1 and 19/20. Now I can borrow from here. So I'm going to borrow there. I'm going to make this 1 and 30/20 minus 1 and 19/20, which would leave me with 11/20. He is so close. 11/20. Now we want to change that into seconds, right? So in order to change it into seconds, we need to have 60 because there's 60 seconds in a minute. So in order to do that, we're going to have to change whatever we do to the top, we do to the bottom, 33 seconds. He just needs to shave off 33 more seconds. 33 seconds. Okay, converting to minutes and seconds is difficult, but I think you can do it. Just use your brains. All right, you can go to your exit ticket. RDW, that means I want to see your drawing. I want to know that you read it. I want you to know that you understand what your units are. And then find your expression and solve, okay? A sandwich for $5.50 and a drink for $2.60, $2.60. So here's a conversion for you, 5.5, and then there's a decimal. She paid for her meal with a $10 bill. How much money did she have left? Write your answer as a fraction and in dollars and cents. So solve it as a fraction first and then convert it to dollars and cents and show me both answers. When you're done with your exit ticket, and this is multi-step, so you need to show all your work. I cannot emphasize this enough. Show all your work. When you're done with your exit ticket, you can go on to your lesson 15 homework. Thank you.